Okay, so next up we're going to do the drilling. So first things first, we're going to check our size. We'd confirm with our drawing this 0.201 is what we want. Looks like a clearance hole for a number 10, so I'm going to pick the nearest size drill bit that I have in my set. So drilling on the lathe is exactly the same as on the mill. The only thing we have to be conscious of is things like our countersync or other features that are going to influence where the start of the hole is and where the back of the hole is. So given that we're going to be doing 3 different drilling ops here, I'm going to split it up a bit, and I'm going to do the common regular drilling first. I'm going to backtrack and do my center drill based on it, and then I'm going to do the countersync last. So we're going to go up to our drilling tab. We're going to grab the regular drill button. Opens just like everything else, asks us to select a tool. We're going to go into our regular tool library for non-ferrous, and we're going to select a drill that is in our set that is closest to that diameter we're drilling. We happen to have a set of number 7s because it's also our tap drill size, so we can spot on pick the exact drill. Only thing we're going to change here, we are going to turn on flood coolant. We are capable of that in this machine. If you end up with a really long drill bit, that's something we will have to address in the machine to make sure the coolant is still able to hit it. Geometry is an interesting one for drilling, right? So we can select it just like we would on anything else, and it gives us the same set of lines that we get. It shows our lead in until the green, it shows where it's going to start feeding, and it shows us this blue circle here. That blue circle is indicating the maximum depth that it is going to cut the full, hole to. Before that blue line up to where the end of the green line is, that's going to be the taper of the tip of our drill bit. So same thing as when we're in the mill. We're going to go to heights and we're going to allow it to drill the tip through the bottom, probably by about 50 thou. Make sure that that's going to break through. Perfect. So with that said, we could exit and we could look, or we can know we're going to have an issue. It thinks the hole ends where we just told it, right? 50 thou offset. It thinks the hole begins at the beginning of the cylinder here. We need it to start at the front of the part. Easy fix. We take the top, we say instead of from hole top, it's going to be from model top. Remember, we've already faced, so we don't have to worry about any of that stock there. We just have to worry about where our model is. The very last thing we have to do, and this is particular to the lathe we run, you can run a regular drilling cycle, right? That'll have no chip breaking. If you want chip breaking, you have to use deep drilling full retract. Partial retract will not work like it does on the mill. So we're going to go ahead and select the full retract. And now we can exit out and we can see what it looks like. And we'll go ahead and we'll do a full stock sim just to ensure that we're not cutting anywhere we shouldn't be. Perfect. Exactly as we would expect. So now we're going to jump in. We're going to use what we've already set up there to create our center drill. So we're going to take our drill here. We're going to duplicate it. So we don't have to redo any of this we had. We're going to edit that duplicate. First things first, we're going to swap that drill. We're going to swap it for a center drill. The tip of our center drills is 0.1, so we just need to match that surface speed. And then the next thing we want to do is in heights, we want to change our bottom from the bottom of that hole to the same thing as our top, which happens to be model top in this case, because we're starting everything up before this counter bore. And we're going to allow drill tip through bottom to break it through, and we're going to put about a 30 thou dimple in there. So we can look at it. We have our blue circle, we have our green line, we know exactly what it's going to do. We're going to run that stock sim just to ensure that it matches what we think. Oh, smart thing to do here would be put the drill 3 above the drill 2 and then run the stock sim. That way we don't get the actual full drilling operation. And we know that that amount will total to being on the the tapered part of the center drill, which is what we need to align that next drill bit. Center drilling on the lathe is an interesting one. If we're running a large batch of parts, we will not center drill each time. We'll center drill the first one, and we'll allow the drill bit to run through where the parting tool is going to go and deeper into the part. That way that hole stays consistent throughout the entire batch. And in that case, we don't need to center drill each time because we have a hole to follow every single time we start the part. But we are down, we have our center drill, we have our drill, we need to do our countersink now. So our countersink can get a bit tedious, but we're going to treat it the same as we would a drill bit. So we're going to go ahead and let's not make a new one. Let's be smart here. We'll duplicate drill 2 again. We'll edit it. First thing we're going to do is we're going to have to select our countersink bit. So we'll go up into tools, not ferrous. And I went ahead and made a tool in here specifically for this. I turned a 1/2-inch drill into an 82-degree countersink. I matched what tool I bought off of McMaster. There's nothing too crazy to it. I'll show that at a different point. Gonna go ahead and turn flood coolant on. We have all our settings right. For our geometry, we're gonna change it up. We will actually be contacting this cone. And then we're gonna go in here. We are not gonna drill the tip through the bottom. We do want to start at the model top, right? Because there is still material all out here. And then we're gonna see what it's gonna do, see how happy it is. So let's go ahead and do a simulation just to double check what everything's gonna look like. We're gonna come in, we're gonna drill, and we're gonna back out. So for a tool like this, we're just imparting that feature that's cutting the tool right on a face here. We don't have a whole lot going on. It's truly as simple as a drill. And all we need to do is go in here to our stock sim, double check. And we can see that as far as our cam is concerned, this yellow where it's cut is intersecting perfectly with the red, meaning that we have everything lined up and our tool set right. Doing it this way with a drill is a large advantage in the sense that if we want to change that bore, right, how deep it is or how shallow it is, we can machine this part and we can go in there and measure and we can just change the Z offset of that one particular tool and that will change the depth of the counter bore and any other features we want to mess with on it. And by not using a tool to make this, we can save a lot of time just at the price of purchasing a tool. And that's all 3 of our drilling ops done. Nothing too crazy to